I'm Anil Kumar, and I'll share a very simple solution to an excellent question on lines and planes. The question here is, a line is drawn perpendicular to the plane 4x minus 5y plus z minus 9 equals to 0 from the point x 3, 2 minus 5. Find the foot of this perpendicular on the plane. So let's try to understand the question first. Let us say that this line represents the plane and we have a point outside somewhere there, and the line from here is to be drawn perpendicular to the plane, and we need to find that point which makes 90 degrees with the plane, right? So that is the question before us. We are given that this outside point x is 3, 2 minus 5, right? And we are also given that the plane here is 4x minus 5y plus z minus 9, right? So that's the equation of the plane. We need to find the coordinate of this point, and let us say that the coordinate of this point is, let's say P. Okay. How are you going to find it? Now, as you can see, the equation of the plane is 4x. Let me write down equation of the plane as equals to 4x minus 5y plus z minus 9 equals to 0, right? So that is the equation of the plane. And clearly from here, the normal is, since it is in the Cartesian form, is 4 minus 5, 1. That is the normal for this plane. Now the normal actually gives you the direction for the line, right? So normal gives you the direction of the line. Because of that, we can now write down the equation of the line itself. So we can say equation of the line will be, a point is given to us. So the point is 3, 2 minus 5. And the direction now is that normal. So we can say a parameter t times 4 minus 5, 1. So that becomes the equation of the line. Now the point P lies on the line and also on the plane. So what we will do now is find a general point on a line, substitute coordinates of that point in the plane, and then find T. Once we know T, we will know the point, correct? So generally, from this equation, general point will be, x value will be 3 plus 4t, right? Y value will be 2 minus 5t, and z value will be minus 5 plus t. So these are general points on this line. The point which lies on the line and also on the plane should be, we'll substitute these values in the equation of the plane, right? So we'll substitute these values in the equation of the plane to get that point and then solve for t, right? So if I substitute these values, what do I get? I get 4 times x value is 3 plus 4t minus 5 times 2 minus 5t plus z, which is minus 5 plus t minus 9 equals to 0. Now this equation is a linear equation in t. We can always solve for t. Let us open the brackets. 4 times 3 is 12 plus 16t minus 10 plus 25t minus 5 plus t minus 9 equals to 0. Let's combine the t's. 16 plus 25 plus t, right? So that gives us, let's use the calculator here. So it is 16 plus 25 plus 1 equals to 42. So we have 42t. And as far as the numbers are concerned, it is 12 minus 10 minus 5 minus 9, and that gives us minus 12. So minus 12 equals to 0, and now we can solve for t. So t is equals to 12 divided by 42. So that is the value of t, which could be simplified. Both can be divided by 6, so we get 2 over 7. So the value of t is 2 over 7. Once we know that t is 2 over 7, we can substitute in our equation and find the coordinate points, right? So let us do that. So we'll substitute 2 over 7 and we get what? We get x equals to 3 plus 4 times 2 over 7, y equals to 2 minus 5 times 2 over 7, and z equals to minus 5 plus 2 over 7, right? So 2 over 7. So these are the coordinate points of point P, which is on the plane and also on the line. Let's calculate these values. So we have 3 plus 4 times 2 divided by 7 equals to 29 over 7. Let's write them. 29 over 7. And we have 2 minus 5 times 2 divided by 7 equals to 4 over 7. And then we have minus 5 plus 2 divided by 7 equals to minus 33 over 7. So we get the coordinate points for P. So our answer is that the point P is 29 over 7, that's the x coordinate, 4 over 7, and minus 33 over 7. So that is how you are going to solve such a question, right? Go through these steps. I think the concept is very simple. So now, and you can solve similar questions. Here is an extension to this, right? So let me extend this question a bit. I would like you to find a point Q which is mirror image of this. So what I'm trying to say is, here is a point X, and find the point Q which is mirror image, means it is here. So point Q which is on the other side and mirror image of point X. So now your question is, find Q which is mirror image of P, and the mirror being the plane, right? So mirror is the plane pi, right? So the plane given to us acts as a mirror. Imagine this to be a mirror, right? In that case, if you see the image of this point inside the mirror, it will be same distance away. You need to now find coordinates of point Q. So that is the problem for you. We'll discuss solution of a similar question in the next video. I hope that helps. I'm Anil Kumar. You can subscribe and learn from my videos. Thank you and all the best.